How's it going, everybody? And welcome back to our Cisco Enterprise Series, where we're going to continue our discussion on the BGP Best Path Selection algorithm with taking a look at eBGP over iBGP. Now, this one's going to be a little bit more challenging to demonstrate, so it's more or less just a revision or a revisit of how it actually comes into play. So there are ways, and it comes into IGP metric to the next hop, which will help to make the determination as to which way you go. So this is one of those things where we go back to an earlier video that we talked about, where if we look at router 26, and let's go ahead and take a look at how this traffic is coming in. So we look at router 26, we do a show iBGP, and we see that we are choosing to go via router 42 versus router 60, and we'll talk a little bit about how that's coming into play. So we'll look at quad 8/32, and you'll notice that we have both an iBGP peering via 60, and we have an eBGP path via, well, technically they're both internal, but XR42 is closer to us than R60 is. So in this particular case, we have to take into consideration that we're going based off the IGP metric. So even though they're both internal to us, even if we were to go to say to XR42 and do a show BGP IPv4 unicast and look at quad 8, like so. One is going to be internal, right? And then one is going to be external. Now, it's kind of a difficult, it's going to choose the external because eBGP is always going to be preferred over iBGP, unless we're dealing with confederation, and then it goes eBGP, then confederation member autonomous system peers, so then confederations, then iBGP. So if there's no confederation, it's going to be eBGP over iBGP. But if there's a confederation in place, it's going to be eBGP, then your confederation ASN peer, then iBGP. So keep that in the back of your mind when you're thinking about how this process works. But in this particular case here, we are, even though 42 is directly connected to both 60 and it's connected to 62, the reason why we're going to go this path here, if we break this down and we look at it, is if we look at metric of 4, we look at, so they're both the same origin code, same metric value. We look at local preference is the same. But because of the fact that this is an external peering, we have one less thing to worry about, which is the metric. So our tiebreaker in this particular case here is going to be the fact that we don't have a metric to take into consideration, so there's no IGP metric. This is going to be the med value for this is going to be your IGP metric. This is going to be your BGP metric, just in case you were curious on that. So that's essentially what's going to end up happening here, and why we're choosing to go this particular path. It's going to be external, right? eBGP over iBGP, unless we were to change the local preference to say 60 and work our way higher up, because now we're choosing eBGP over iBGP, and you really can't do that. Now, if we go back to 26 and we look at this, even though they're both internal paths, the reason why we're going to look at this one is best is because the metric is lower. So this is one of those times where you would be like, okay, well, I can go bump the cost up to my loopback on 42 to be, say, 10, and that would make this a metric of 12, which would make 60, should theoretically make it the better path. So because of the fact we can't really demonstrate eBGP over iBGP because of just the way that it works, what I will do is I will combine that and IGP metric to the next hop. So what I'm going to go do is I'm going to go to 42, and I'm going to do a show IP interface brief. We have a loopback So interface loopback 0. And we're doing OSPF in here, so I'm going to type in, actually it's going to be router OSPF 1. We're going to type in area 0 and interface loopback 0. I'm going to come in here, I'm going to specify the cost. I'm going to bump this up to be, let's say, a cost of 5. I'm going to go ahead and I'm going to commit that change. And then once that's done, I'm going to go back over here to 26 and hit the up arrow. And as soon as this guy updates, let's do a show IP route. We should see. Oh, you know why? Well, it's coming in as 2. Cost of 2. I might have to go to the interface level of gig 0/1 for it to trigger. Yeah, I think that's what I'm going to do. I don't think the loopback is going to be sufficient enough. So let's go to interface gig 0/0/0/0. Actually, you know what? It's going to be local. It's, no, actually, I could try it here. So we'll type in interface gig 0/0/0/0/1. Type in the cost is going to be 5. Show config failed. Interface already exists in OSPF. Let's just do abort. Router OSPF 1 area 0 interface gig 0/1 cost of 5. Show config failed. Why did that fail again? Interface already exists in OSPF process. I know. So what the heck? So let's go back to 26 and see. I'm waiting for the, this is the cost. So why am I do show run router OSPF? Oh, duh. That explains it. Duh, I forgot about that. We'll go back to here. And then area 0, interface gig 0/0/0/0/1. Actually, you know what? Take that back. I'm mistaken here. I need to go do this on R26 on gig 0/1. So interface gig 0/1, IP OSPF, or do show run section OSPF. This is going to be interface level config, so it's going to be interface gig 0/1 is going to be IP OSPF cost. We'll give it a cost of 5. Now if I do this again with the show IP route, we should see my intention. There it goes. So now it sees it as 6. Right now if I do show IP BGP, and now we're going to choose 60 as the best path. So if I pull this guy out, now we're going to see 60 as the preferred path because the iGP metric to the next hop is lower. So that's how you would affect that. So you can do this. This is, again, we're getting further down the best path selection algorithm process, so it's going to become more challenging to manipulate this traffic and things like that. So with that being said, that's pretty much what I wanted to demo for you guys in this video and show you guys how to change the directionality of traffic. And if I was to pull up PC68 and do a trace route to quad 8, we're going to go 60 to 62. So now we're going 11 AS hop or 11 hops to get to where we want to go. So that's essentially what I wanted you guys to see in terms of that. So this is going to be a combination of eBGP over iBGP and then iGP to the next hop, because it's, you know, like I said, I can't really manipulate eBGP over iBGP. You'd have to go down to something further down in that respect. So could you convert an iBGP path to an eBGP path? You could. And you could do vice versa with, you know, iBGP to eBGP. However, that's not always going to be the case. So because you can't always easily do that, you need to, there's other things further down the road which are going to be obviously changing the cost to the next hop. That's one thing you can do. So, but now that they're the same, we should be in pretty good shape. So the other one that we could do is we can make, we'll talk about router ID next, because if we look at our process here, we took a look at IGP to the next hop, and if you have equal multipath, then you can go based off lowest router ID. So we'll circle back to that here in just a minute in the next video and talk about that. So with that being said, I want to thank everybody for stopping by and hanging out with me. If you have any questions, comments, concerns, feedback, drop a comment in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you guys next time.